Okay, this is part 4, slideshow on reverse osmosis. This is a standard element, about 8 inches by 40 inches long. They have a fiberglass shell on the outside. Back here is the element interconnector. This is a newer style. This has a little tube with O-rings that slides in the ends. The older style, they went together and twist locked together. A little more difficult to use. So that's why they can be crushed under high pressure. This fiberglass shell can be crushed. Okay, this shows the end. These are the anti-telescoping device. Right in here you can see the mesh. This is probably a 34 millimeter spacing. They have different thicknesses of spacing, depends on the water and what you're doing. Here's the permeate. This is where that permeate interconnector will go. As you can see, it's a spiral wound. You can see these spirals coming out. I'm not sure how many leaves are in this one, but there's quite a few, probably 10, 12 or so. So the water goes, this would be the water coming out. The brine seal's on the inlet end, on the other end of this. So you can see the spacing is pretty fine in here. It don't take much to plug these up. That's why your water treatment is so critical, feeding these. Just another close-up, you can see the spiral winding on it. If you get these with really high pressure, it can break these plastic out, and it can shove out the feed spacer or the mesh we mentioned earlier. This just lays in here loose, and this right here is the reverse osmosis leaves. So there's 2 layers of membrane, and then there's a permeate carrier inside of that. This shows the brine seal. Down here is the interconnector that goes with this unit. These can only go in the pressure vessel one direction. This will be the flow coming in, so this is the brine seal. So in order to take this out, they have to go down the pressure vessel. You have to pull them all out the direction of flow, then put them back in the other end. You can't pull them through backwards. Okay, this is the permeate outlet. This will be the inlet end. As you can see, there's a ring right here. You can pull this out. It's like a spiral wound ring that locks in the cover plate to the shell. These ROs will have to go in this direction, the elements, to change them out. This is a sample port, so you can check the permeate out of each element. So if you have a failure in one of the brine seals or the membranes being damaged, you'll pick up higher conductivity on these. Just kind of a handy troubleshooting item. Check valve right here. This is one of the sample panels. These are pH probes, conductivity. Conductivity probes do pretty good. pH are very temperamental. They don't like high purity water, and the temperature creates quite a problem with them. Another sample station. This is a little more elaborate control system. Now you got flow transmitters down here. Basically your sodium metabisulfite's coming in down here. You have your ORP and your inlet pH here. Most of these are pH and a lot of conductivities on the unit. Just another view of it. Back here's the filter. Shows some of the piping and how compact these units can be. This is the side view of the RO. On this one, the elements would have to come in this end and come out here. So if you want to change elements, you have to pull them out this end, push them through. The elements have to be discharged out here, and they got to be put back in here. You can't put them in backwards. You have to use a lot of glycerin too. That helps for getting them in. Notice there's a relief valve here. They have quite a few relief valves on these so you don't overpressurize and damage stuff. Quite a few little flow transmitters. This piping is the clean in place piping on the unit. This shows the feed end of it. This here will be the first stage, first pass. First pass, first stage. First pass, second stage. On the side view, these have one less element than these, so it's kind of a tapered array. Back here, second pass. This is first stage, second pass. Second stage, second pass. So it's clean in place piping, and they're a pretty good little skid unit. They're quite compact. Another view of the end. It shows these two here that have one less element. They're a little smaller pressure element. This is all first pass here, second pass here. Drain water comes out down here, concentrate. Okay, this shows just a little more of the piping on the unit. It's your first pass VFD pump. Just threw this in to show kind of how complicated the piping can be. Another end view. This is the filter, the inlet filter. Usually these should be like a 5 nanometer, which just takes out the big particulate. That's why you have to have super clean feed water coming in. Your SDI was a 0.45 nanometer filter you were checking with. So these just get the large particulate out. You really can't rely on these to clean up your feed water. In here you have your chemical injections, be your biocide anti-scale. Back here is your sodium metabisulfite going in to get rid of any chlorine. This one had a pressure regulator. Here's your filtered water coming in. I got a pressure regulator to drop the pressure for the unit. These are the two VFD pumps. This is the first pass pump, second pass pump. Here's your inlet flow meter. Pretty nice flow meter on this one. I think it's magnetic flow meter. This is an interstage flow meter. I believe this is the second pass. This is the first pass flow meter, showing about 68 gallons a minute permeate coming out. These are handy for troubleshooting, as we showed on the whiteboard. If you notice the flow starts dropping off in the first pass, then you're probably fouling with biologicals or silt. And if it starts dropping on the second pass, then you're probably scaling. Just kind of a troubleshooting. This is a little valve. I mentioned about a flow control valve on the permeate. These are not isolation valves, shouldn't really touch it. These things have a lot of butterfly valves on them. You can see the check valve on the permeate coming out. This is collecting all the permeate coming out of the first stage. It's all stainless steel piping. Carbon steel wouldn't last long, and plastic it's not as durable. This is your concentrate back pressure control valve. These are the ones that determine your recycle. These are set initially and left. They'll give you like your 85% recycle rate, recovery rate. If you adjust these while you're running, then all your data is no good. You don't really know where you're at on the unit. These can be adjusted if after you do a CIP and you have data that shows that you could get a higher recovery rate. But mostly these are left alone. This shows the second pass. This is the chemical feed pump skid. You have your different chemicals. You have your biocide, anti-scale. Actually, this is bisulfite, and this would be your anti-scale here. So these pumps, you have to pay attention, make sure you're actually putting in the chemical like the anti-scale, and your bisulfite's really critical. This is the clean and place skid. I get your tank, pump, heater. There's the filter and the heater back here. So if your ROs start plugging up, start losing efficiency, then you have to run a clean in place, use different chemicals. You kind of need to know what you're cleaning for before you start. Is it a biological problem? Is it iron, calcium, silica? Each of these issues are treated a little differently. Another view of the clean in place skid. And that kind of concludes the slideshow. Big thing with ROs, you need to do a lot of hand samples to make sure the pH conductivities are correct. You're not putting chlorine in during startup and your anti-scales are being fed. Other than that, once they're set up, they run pretty good. And that concludes this. Thank you.